Hello everyone, welcome to Eureka Math / Engage New York Math, Module 1, Lesson 23, Problem Solving Using Rates, Unit Rates, and Conversions. I'm Mr. Quick, and I'm ready to get started. When it comes to problem solving, I think that the last few lessons can be a little bit complicated in the sense that we spend a lot of time thinking about the different equations and different ways you can do, or you can find distance, rate, and time. I think when it comes to the problem solving, it becomes a little bit easier, and I'm going to show you some ways to do this and hopefully give you a few, I hate to say shortcuts, but maybe some math hacks and some ways to do this a little bit faster but still come to the right answer. Let's get started. Okay, here's an example. Fresh cut grass. Suppose that on a Saturday morning you can cut 3 lawns in 5 hours, and your friend can cut 5 lawns in 8 hours. Who is cutting lawns at a faster rate? Okay, to help me keep this straight, I'm going to say, here's me, and here's my pal, my friend, right? So I can cut 3 lawns in 5 hours. So 3 lawns, oh, good enough, in 5 hours. Your friend can cut 5 lawns in 8 hours. Now, there's a few ways we could do this. We could say how many lawns in 1 hour, in which case we would, in this case, divide by 5. And over here, we would divide by 8. And what you'd end up with is 5 divided by 8, because you'd have to do the same thing up here, and 3 divided by 5. And then you'd get, in this case, 0.6. In this case, you get 0.625. And you would see, hey, it's very, very close, but the friend is cutting a little bit faster because they're cutting 0.625 lawns in an hour. You're only cutting 0.6. That's one way to do it, and I didn't even do the math part there where we actually had to do that division. I'm going to show you another way we can do it. Okay, going back to our original problem. You see that this is me again, right? 3 lawns in 5 hours. This is my friend, 5 lawns in 8 hours. Well, we are comparing these two things, and we basically have 2 fractions right here. So we can compare the fractions, but we just have to make sure that we get a common denominator, right? We can't compare apples and oranges when we look at fractions. We have to have a common denominator. So I know if I look at 8 and 5, right? 5, 10, 15, 20, 25, 30, 35, 40. 8, I would look at 8, 16, 24, 32, 40. They both have 40 in common. So I'm going to want to figure out each of these in 40 hours because, yes, it does help if you're trying to find out how fast they are. It does help to find out how many lawns they can cut in 1 hour. But as long as the hours are the same, we'll know who's faster, right? We'll know who does a faster job in 40 hours. So to get from 5 to 40, we used our constant, which is times 8. And to get from 8 to 40, we have to do times 5. So since we did 5 times 8 equals 40, we also have to do 3 times 8, which gives us 24 lawns. So I am cutting 24 lawns in 40 hours. Over here, 8 times 5 gives us 40, and then we have to do 5 times 5, which gives our pal 25 lawns. And so the pal is cutting faster than us because he or she can cut 25 lawns in the same amount of time that we can only cut 24. Now, it's really close. It's only 1 more lawn out of 40 hours. It's really close, but we've now found out who is faster. Okay, let's look at another problem here. Suppose you own a restaurant. You want to do some advertising, so you hired 2 students to deliver takeout menus around town. One student, Darla, delivers 350 menus in 2 hours. Another student, Drew, delivers 510 menus in 3 hours. You promise a $10 bonus to the fastest worker since time is money in the restaurant business. Who gets the bonus? Well, really quickly, you're giving a $10 bonus. Does that matter? No. That's another number thrown in there to see if you'll just look at all the different numbers and figure out something to do with all of them. You don't need to worry about the $10. That only matters to Carla and Drew, or I guess Darla and Drew. Okay, just like I did before, I'm going to do two different sides here to kind of keep it straight. I've got Darla, I got Drew. Darla delivers 350 menus in 2 hours. Drew delivers 510 menus in 3 hours. I need to find out how many menus they deliver in the same amount of time, right? We've got 2 hours, we've got 3 hours. Let's see what we can figure out. Okay. I want to find out how many menus Darla can deliver in 1 hour. To get from 2 to 1, we have to divide by 2. That's our constant, our magic number. So then up here, I'm going to divide 350 divided by 2. And I'm going to end up with 175 menus in 1 hour. So Darla delivers 175 menus per hour. Over here, let's do Drew. Drew, we want to get from 3 hours to 1 hour. So magic number, or our constant, is 3. 3 divided by 3 is 1. Got to do the same thing up here. 510 divided by 3 is going to give us 170. So Drew delivers 170 menus per hour. And so who gets the bonus? Darla delivered more menus. Darla should get the bonus. Sometimes with a problem, we should always use kind of the fastest route, or that gets us to the right answer, as long as we're comfortable with it. And sometimes we can overthink it. Here's an example of when that could be possible. It says, which runs faster? A cheetah can run 60 feet in 4 seconds, or a gazelle can run 100 feet in 8 seconds. So I'm going to say cheetah, gazelle. Over here we're going 60 feet per 4 seconds. Over here we're going with the gazelle, going 100 feet in 8 seconds. What I noticed instantly, and I hope that maybe you did too, was that if you look, 4 seconds and 8 seconds are almost comparable. I can really easily go from 4 to 8, right? I just have to multiply by 2. If I do that, I got to do it up here too. So the cheetah, 60 times 2 is 120 feet. 4 times 2 is obviously 8 seconds. So now we know how fast each of them goes in 8 seconds. The cheetah goes 120 feet. The gazelle goes 100 feet. So in 8 seconds, or in the same amount of time, who ran faster? Which animal ran faster? The cheetah ran faster. Pretty simple, right? Okay, let's do one more example and change it up a little bit. Okay, what if the units of time are not the same in the two rates? What does this mean for the rate units? Here's the question. It starts right here. The secretary in the main office can type 225 words in 3 minutes. Okay, so I'm going to say the secretary. Ugh. There's no bueno. Okay. Secretary is going 225 words per 3 minutes. The computer teacher, we'll just say comp, can type 105 words in 90 seconds. Now hold on a minute. We may have a problem, because now they're asking us to compare. Over here we've got seconds, and over here we've got minutes. Well, what can we do? Well, here's what we can do. We know that the secretary types 225 in 3 minutes, so we can convert minutes into seconds, right? 3 minutes, I know there's 60 seconds in a minute, So in 3 minutes, it would be 3 times 60 is going to give us 180 seconds. If we do this down here, then we've got to do this up here, right? Actually, wrong. The reason is we didn't multiply, so it looks like, oh, you did 3 times 60, but 3 minutes is 180 seconds. We didn't change anything. So the secretary still types 225 words per 180 seconds. So it's not like we changed anything, we just changed the unit. We didn't actually change the number. So we've still got a problem here, because here we have 180 seconds, here we have 90 seconds. We don't have the same information. What I hope you may be noticing, though, is 9 and 18, right, multiples. So I know that if I multiply both of these by 2, now I'm going to have something comparable. So that gives me 180 seconds here. 105 times 2 would give me 210 words. So in the same amount of time, 180, 180, the secretary types at a faster rate. She can type 15 words more in those 3 minutes than the computer teacher could type. The other thing that we could do is say, okay, we want to boil this down to 1 second on each side, right? So in this case, to get from 180 to 1, we've got to divide by 180. Now, if you throw that in your handy-dandy calculator, you're going to end up with 1.25 words per second. Over here, to get from 90 to 1, we've got to divide by 90. So we've also got to divide 105 divided by 90, and you would get essentially 1.16 words per second. So, same situation, secretary types just a little bit faster. Okay, I'm running out of time on my video here. We'll do some more examples together in class. Thank you for watching.